Today, we will see what is an undefined rational expression. Now, the idea here is when you write a rational expression, which is rational is basically another way to say a fraction, you need to exclude the numbers that will make the denominator equal to 0. So we are going to start simplifying some expressions, and then once we're done simplifying, we're going to see which number will make the denominator equal to 0. So let's see some examples here. Simplify the following expression, and then we need to exclude those numbers that will make the denominator equal to 0. Okay. So let's see. Can we simplify? Let's see. Can I factor anything out? Well, notice that it's already in factor form. Denominator, multiplication. So we see that x plus 4, they cancel out. So now we have 1 over x minus 3. So this is the simplified version of our original problem. Now, I need to exclude those numbers that will make the denominator equal to 0. Okay, so which number for x will make the denominator equal to 0? So I see that if I plug it in 3 on the denominator, I will make it 0. So that means that when x is 3, the denominator is equal to 0. And when you have a denominator of 0, that's undefined. So we need to exclude that number. We cannot use x equals to 3, because if I use it, I will make the denominator equal to 0. So this is our answer. And you also have to point out that x cannot have a value of 3, because if x is a value of 3, you will have a denominator 0, so you will have 1 over 0, and this is undefined. And we don't ever want that. We don't want undefined numbers. So this is our final answer, is the expression. And also, you have to point out what number needs to be excluded. So let's look at a more complicated example here. Example 2. Now, again, let's try to simplify. Look at the numerator. Can you factor anything out? No. So let's just rewrite it. Look at the denominator. Can you factor out the denominator? Well, let's see. How can I factor x squared plus x minus 72? Well, I see that it's a trinomial. So three terms. Leading coefficient is 1. x1 is 2. So I can use the x method. Where the x method says the number that goes on top is the multiplication of the first and the last. So that's minus 72. Minus 72 times 1, minus 72. The number in the middle goes in the on bottom. So now I need to find out two numbers that if I multiply them gives me negative 72, and if I add them up gives me 1. 8 and 9 will do the trick. Now it's negative 8 because I want negative 72. So negative 8 times 9, it is negative 72. Negative 8 plus 9, it gives me 1. So that means that I can rewrite the denominator as x, the first number, which is minus 8, and x, second number, which is 9. Alright, so now that I have some factor form, notice that the x minus 8 will cancel out. So now I have 1 over x plus 9. So this is our final answer, but I also need to exclude the number that will make the denominator equal to 0. So here the number that I need to exclude is negative 9, because if I make x equals to negative 9, I will have the denominator 0, and I don't want that. So this is my fully answer. Have an expression. Which number you need to exclude? Negative 9, because negative 9 will make the denominator equal to 0. So the process still remains the same. Simplify and see what is it that you can exclude. So let's see, numerator. Can I factor out the numerator? No, I can't. So let me just rewrite it. Denominator, I can factor it out. How? I can use the x method. So number that goes on top, 1 times negative 7, denominator, that's 6. Two numbers that if I multiply them gives me 7, and add them up gives me 6. So 7 and 1, and negative 1 has to be negative because 7 times -1 is -7. 7 plus -1, that is 6. So that means that the denominator, I can rewrite it as a plus 7, a minus 1. Okay, notice that here the a plus 7 will cancel out. So now I have my final answer is 1 over 1 minus a. So which value of a I need to exclude? In this case, it will be 1. Because if I substitute 1, I will have 1 minus 1. I will make 0 in the denominator, and that's undefined. So that's why I need to exclude that number. So this is my final answer. The simplified version of the original, and you need to tell me which number it needs to be excluded. Okay, so now let's look at our last example. Same idea here. Can I factor out the numerator? No, I can't. So that's that. Rewrite it. Can I factor out the denominator? Which method can I use? I can use the x method. So let's choose for x method. Two numbers that if you multiply gives you 25. And a number that if I add them up gives me -10. Well, that will be yeah, what will be that number? Two numbers multiply 25. Add them. Oh, okay, 5 and 5. Okay, 5 times 5. Oh, how about -5 and -5? -5 times -5, it is positive 25. -5 plus -5, it is -10. So that means that I can rewrite the denominator as b minus the first number, which is -5, b minus the second number, which is -5. Alright, so now we have this. Notice that the b minus 5s will cancel out. So now I have 1 over b minus 5. Okay, it's not a good 5. Let's rewrite that 5 here. Well, make much of a difference. Whatever. Now, b should not be equal to 5 because if you plug in b for 5, you will have denominator 0, and that's an undefined number. So we need to exclude b equals to 5. Now, here's your entrance ticket. Simplify the following and also indicate what values you need to be excluding.